All right, we're going to take a look at the voltage drop that we talked about on this first circuit here. Now, this circuit that we built up was a little bit different because it finally had the power circuit up here, which was my three-phase line 1, line 2, and line 3. This was my high voltage up here. We ran through a transformer, and then we had a control circuit, okay? And so what we're wondering was, you know, when we brought the voltage down, and the motor started to chatter because it was getting lower and lower and lower and then dropped out. What are we talking about? The effect of the voltage is it seen by the power circuit and the control circuit. So the first thing to recognize is that this is a center tap transformer. This is the lab volt transformer right here. That's what that's showing. It's not the industrial control transformer where you put it in series and parallel. It's just you pick off the center tap that you want. And what this did is this provides 208 on the primary and it provides 120 on the secondary, okay? And so if you do the ratio from 120 to 208, 208 divided by 120, you get 1.73. So this was a step down. It steps the voltage down of 1.73 to 1. Remember, the industrial control transformer is 2 to 1 or it's 4 to 1, okay? But we were stepping it down from 208 to 120. So at this point, when we brought this voltage down, it started to chatter a little bit, okay? And it maybe dropped out when it got to 60 volts, okay? So we had 60 volts here. And then we had the 1.73 was the ratio. I'm asking, what is the voltage up here on the power circuit? Because really that's what would be happening. The three-phase voltage would be going lower and lower and lower, and the transformer would not be as efficient. It would be dropping and dropping, and so that we would get voltage here. But really it's the line voltage up here that dropped. So what is the X right here? Well, in that case, what we have to do is we have to take the ratio here and just make it equal so that it's the same up here. So we're going to bring 60 over here. We're going to multiply this side by 60. So 60 times 1.73. So we're saying that we've got 103 volts. 103.8 volts is what I'm getting right there. 103.8 volts. Wow. So that's pretty interesting because that means that this voltage up here between the three phases was dropping down to 103.8. And when you run the transformer, 1.73 steps gives you about 60 here. So 103.8, that, or 104, is pretty low voltage. So not only would this relay chatter and drop it out and cause it to stop, but as it was falling, this motor would not be very happy because this motor wants to run at 208 three-phase 60 hertz. But as it's running down to 200, 190, 180, 170, 160, all the way down to like 100, 110, 105, 104 volts, this motor will not be happy. It will also maybe start making noise, and it might not have enough voltage to actually run the device that it's hooked up to. So that means it might stall, okay? And at that point, this might not have dropped out yet, opening these contacts here. So this motor might be running at some really low voltage, you know, 103.8, even if it's 110 or 115, 120, that's gonna possibly damage this motor right here, and it would cause it to either burn up or it could run really hot. But in this case, what we would hope would happen is that it started running hot and it was trying to do the work, but it just didn't have enough voltage. Maybe these overloads would get really hot, causing this circuit to open, causing this to open, and causing these to open and shutting it down, okay? So when you get a low voltage situation here, when this starts dropping, because the transformer's got a ratio here, the voltage between line and one start dropping as well, and you hope that somehow this control circuit drops out before the motor burns up, because ultimately line 1, line 2, and line 3 are getting some pretty low voltage situations, and that could cause that motor to get damaged.